Starting with the next exercise, exercise 4.5. Verify A into adjoint of A is equal to adjoint of A into A, which is equal to determinant of A into I, and A is given like this, students. So what we have to do here is, we have to find out what is adjoint of A, determinant of A, do the given operation here and see whether each term is equal to each other or not. So this is what we have to prove. So let us start with finding out the adjoint of A. So solution. So as we have discussed in the synopsis, so there is one shortcut to find out the adjoint of A. This is applicable only for 2 cross 2 matrices. How do we find out the adjoint of A is? Adjoint of A equals, so what you have to do here, students, you have to interchange the elements of principal diagonal. So what is principal diagonal here? This is the principal diagonal, right? Interchange the elements. So what will happen? Minus 6 will go there, okay, and 2 will come down, correct? And the other step what we have to do here is, let this diagonal be as it is, but inverse the sign. So this has plus sign, right? Right, minus 3, and this has minus 4, write it as plus 4. So this will be our what? Adjoint of A. So this is a shortcut, students, okay. So if you want to do it step by step, then you have to take out what is the minor of 2. So what is the minor of 2? Again here we'll write adjoint of A equals, what is the minor of 2, students? Minor of 2 is minus 6. What is the cofactor of 2? So we'll write the cofactor like this, okay. Cofactor of 2 is plus, so plus into minus 6 is minus 6. What is the minor of 3? The minor of 3 is minus 4. Minus 4 into the cofactor of 3, minus. So minus into minus will become plus. So minor of minus 4 is 3. Cofactor of minus 4 is minus. So this will become minus 3. And minor of minus 6 is 2. 2 into the cofactor of minus 6 is plus 2. So plus 2 as it is. So is this the right answer? No. So what we have to do here, we have to take the transpose of this. So once you take the transpose, become minus 6, minus 3, 4 and 2. So this will be our adjoint. So to take adjoint by a conventional method, you have to follow 2 steps. One is find out the minors of the given matrix A. After finding out the minors, take out the transpose of it. So then you will be getting the adjoint. So here if you see in the shortcut, within 1 step only, we are getting the adjoint of the matrix A. So how do we get this? Interchange the principal diagonal elements and inverse the signs of the other diagonal. You will be getting adjoint of A. Understood? So moving on with the next one, let us find out the determinant of A here. So determinant of A will be equal to 2, 3, minus 4 and minus 6. So find out the determinant of this. So what will happen? Minus 6 into 2 is minus 12. Default sign is minus. Minus 4 into minus 3 is minus 12 again. So minus into minus is plus. So this will be equal to 0. Understand? So further, now we'll start with this operation A into adjoint of A. So what is our A? 2, 3, minus 4, minus 6. Into adjoint of A. Adjoint of A is minus 6, minus 3, 4 and 2. So this is A into adjoint of A. This must be equal to what? Adjoint of A into A. So again we'll write adjoint of A, minus 6, minus 3, 4 and 2. A again can be written as the same thing, 2, 3, minus 4, minus 6. This again should be equal to determinant of A, which is equal to 0 here. So we'll write determinant of A, 2, 3, minus 4, minus 6 into I. So I matrix, we'll write it as it is, of order 2 cross 2. Now do the matrix multiplication here. So the orders are, the number of columns in A is equal to the number of rows of B. So therefore matrix multiplication can be carried out. So 2 into minus 6 is minus 12. 3 into 4 is plus 12. Minus 12 plus 12 is 0. 2 into minus 3 is minus 6. 3 into 2 is plus 6. Minus 6 plus 6, again we will be getting 0. Minus 4 minus 6 is plus 24. Minus 6 into plus 4 is minus 24. Plus 24 minus 24 is again 0. Minus 4 minus 3 is minus 12. Minus into minus is plus 12. Minus 6 into 2 is minus 12. So again we will be getting here 0. So this is what? This is the product of A into adjoint of A. So moving on further, adjoint of A into A we'll find out. Minus 6 into 2, minus 12. Minus 3 into minus 4, plus 12. So again we'll be getting a 0 here. Continuing this further, minus 6 into 3, minus 18, plus 18, 0. 8 minus 8, 0. 12 minus 12, 0. So these both are equal to each other. Now we have to show this is again equal to, so what is this determinant of A? Here you see, determinant of A is again equal to 0. 0 into I will be again equal to 0. So therefore we can write, therefore, hence, proved. So we have proven whatever was given for us. So here what is very important, students? The matrix A will be given, right? To find out the adjoint of A by conventional method, 2 steps must be carried out. If you want to find it out by shortcut, interchange the principal diagonal elements and inverse the signs of the other diagonal. So once you do that, the other elements are already given. Find out the determinant of A, multiply the adjoint with the given matrix A, and it will be 0 throughout. Okay. Moving on to the next question. Same thing we have to do. A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I. So we'll directly start with adjoint of A. So to start with, so this is applicable only for 2 cross 2 matrix, right? For 3 cross 3 matrix, what we have to do is, the very first step is take out the adjoint of A. Solution. Adjoint of A. So here we will write transpose first. So if you have to take the transpose, 1 minus 1, 2, 3, 0, minus 2, and 1, 0, 3. So the very first step is taking out transpose. We cannot apply this method here. Why? Because this is applicable only for 2 cross 2. For 3 cross 3, you have to follow the conventional method as mentioned here. So first we took out transpose. Now write the cofactors for each and every element. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Find out the minors of each and every element here. So that will give us the adjoint. So now finding out the minors. So these both are gone. 3 zeros is 0, minus 2 zeros is 0. So 0 into plus, so that will become 0 only. So again minus, these both are gone. 3 into minus 1, minus 3, minus 2. 3 into minus 1 is minus 3, minus 2 is minus 5. Minus 5 multiplied with the cofactor of 3, it will become plus 5. Next, minus 2 into minus 1 is plus 2, minus 0. So plus 2 into plus is 2 only. Next, 9 to 11, minus 11. So this will give us 3, minus 2, 1, 1 as it is. So this will give us minus 2, minus 6, minus 10, multiplied with this, it will become plus 10. So this will give us 0, this will give us 0 plus 1, so it will become minus 1. So this will give us 0 plus 3, 0 plus 3 is 3, 3 into 3, okay. So this is our adjoint of matrix A. So everything is fine, we'll just check this term once. Minus 2, minus 2, minus 6, minus 2, minus 6 is minus 8. Minus 8 multiplied with this, it will become plus 8. So this, there was a mistake here, calculation. So this will become plus 8. Apart from this term we'll see now. 3 into minus 1 is minus 3. Minus 3 multiplied with the cofactor minus, that will become plus 3 here. So this is also plus 3. So this is our adjoint of matrix. So these both terms were mistaken. So be careful when you are finding out the adjoint of A. Any one term becomes a mistake, okay, you will not be getting the right answers. So there was some mistake here, calculation, which have been corrected. So this is our what? This is our adjoint of A. So now let us find out the determinant of A next. Determinant of A, which is equal to this as it is, 1 minus 1, 2, 3, 0, minus 2, 1, 0 and 3. So it is plus, minus and plus. So plus 1 of 0 minus 0, minus of minus 1 of 9 plus 2 and plus 2 of 0 again, correct? Plus 2 of 0, this is also becoming 0, minus into minus 1, 3 3s is 9, plus 2 is 11. Okay, so this is becoming 0, this is also becoming 0, therefore determinant of A will be equal to, minus into minus is plus, plus 1 into 11 is 11 only. So this is the determinant of A. Now what should we prove? We must prove this product is equal to this product is equal to this product. Alright. So we'll start with this A into adjoint of A. A into adjoint of A. So this is written as 1 minus 1 2, 3 0 minus 2, 1 0 3. Into adjoint of A. Adjoint of A is here 0 3 2, minus 11 1 8, and 0 minus 1 3. Matrix multiply this. So what will you be getting? Rows into columns. So here we'll write. So mental calculation will do, students. 1 into 0, 0, minus 1 into minus 11 is plus 11, 2 into 0 is 0 again. So here we are getting 11. Alright. Next, first row into first column is done. First row into second column now. 1 into 3, 3, minus 1 into 1, minus 1. So 3 minus 1 is 2. 2 into minus 2 is 0. Okay. Next, first row into third column. 1 into 2, 2, minus 8, 6. So 8 minus 8 is 0. Okay. Next, second row first column. 3 into 0, 0, 0 into minus 11 is 0. Minus 2 into 0, 0 again. Second row into second column, 3 3s is 9. This is 0 again. Minus 2 minus 1 is plus 2. So 9 plus 2 is 11. Second row third column, 6, 0, minus 6. So it is 0 again. Next, third row into first column, 0, 0, 0, 3, 0, minus 3, 2, 0, 9. 9 plus 2 is 11. So what is this? This is our A into adjoint of A. Next, what should we find out here? A into adjoint of A we found out. Next, adjoint of A into A. So here we'll write adjoint of A into A. So this can be written as adjoint of A 0 3 2. Minus 11 1 8, 0 minus 1 3. This is adjoint of A. And A as it is 1 minus 1 2, 3 0 minus 2, 1 0 and 3. Again matrix multiply this. See what will you be getting. First row into first column, 0, 9, 2, this will become 11. First row into second column, 0, 0, 0. First row into third column, 0, minus 6, plus 6, 0. Okay. Second row into first column, minus 11, plus 3, plus 8. So minus 11 plus 11 is again becoming 0. Plus 11, 0, 0. So plus 11 as it is. Minus 22, minus 2, that is becoming minus 24, plus 24. So this will again become 0. So 0 into this is 0 again, minus 3 plus 3, 0. Third row into first column. Third row into second column, 0, 0, 0. And the last one, 0 into 2 is 0, minus 1 into minus 2 is plus 2, 3 3s is 9. 9 plus 2 is again 11. So this is our what, students? This is our adjoint of A into A. This is also done. So determinant of A we already found out. What is determinant of A? Determinant of A is equal to 11. 11 into I. So that will give us 11 into 1 0 0 0 1 0 0 0 1, which is equal to 11 0 0 0 11 0 0 0 11. So what is this? This is our determinant of A into I. Now see whether all the three quantities are equal to each other. So this is our first quantity, second quantity and the third quantity. So all are the same, right? 11 in the principal diagonal, the other elements are 0, which means we have proved this for the given matrix. Moving with the next question. Find the inverse of the matrix if it exists. Now students, how do we know whether this matrix is having an inverse or not? So we have one condition. If determinant of A is not equal to 0, so then what we can tell? Then we can tell, so this implies inverse exists. Okay, inverse exists. So here we'll start. Determinant of A will find out. So to check whether inverse exists or not, solution. Determinant of A will be equal to minus 2 plus 15, which is equal to 13, which is not equal to 0. Therefore, inverse exists. Understood? So the determinant of A should not be equal to 0, then only we can tell that the inverse exists for the given matrix. Now we have to find out the inverse of this matrix, right? So previously what were we doing? Previously we were using the row transformation to find out the inverse of the matrix, but here, as we have discussed in the synopsis, we will be using a formula which is given by inverse of matrix A is equal to adjoint of A divided by determinant of A. What is the determinant of A, students? Determinant of A is equal to 13. Check that out once. 2 into minus 1 is minus 2, plus 5 into minus 3 is minus 15, so it will become plus. Plus 15 minus 2 is 13. Okay, adjoint of A, can we write this very easily? Correct? What is adjoint of A? For 2 cross 2 matrix, interchange the principal diagonal elements, 2 minus 1, inverse the signs, minus 5 and 3. So this is our adjoint of A. So adjoint of A we got, determinant of A also we have here already 13. So therefore A inverse will be equal to how much? A inverse will be equal to adjoint of A 2 minus 5, 3 minus 1, the whole divided by determinant of A is equal to 13. So this again can be written as A inverse equals 1 by 13 of 2 minus 5, 3 minus 1. Multiply this inside, therefore A inverse will be equal to 2 by 13 minus 5 by 13, 3 by 13 minus 1 by 13. So this is our A inverse. Moving on to the next question. Same thing, we have to find out the inverse of this. Before we start with calculation, let us find out whether inverse exists or not. So finding out the determinant of this, what we'll be getting? Plus 1 of 8 minus 6, 8 minus 6, minus 1, minus into minus, that will become plus 1 of again, 0 plus 9 and plus minus plus. So plus 2 of cofactors, 0 minus 6. So solve this. 1 of minus 2 plus 1 of 9 plus 2 of minus 6. So this will give us minus 2 minus 12 plus 9. So this is becoming minus 21 plus 9, which is equal to minus 12, which is not equal to 0. Therefore inverse exists. Check this once again. 4 2s are 8. Minus into minus is plus, default sign is minus again, so 8 minus 6. Minus is there already, minus 1. Here the cofactor is also minus, so minus into minus is becoming plus. 4 into 0 is 0. 3 into minus 3 is minus 9. Minus into minus is becoming plus. Next, plus 2 of minus 2 into 0 is 0. 3 into 2 is minus 6. So this is becoming minus 6, 9 and minus 2. Minus 6. So this is becoming minus 12. Minus 12 minus 2 is minus. Okay, so there is one mistake here. Minus 6, minus 12 into minus 2. Minus 12 into minus 2 is minus 14. Minus 14 plus 9. Minus 14 plus 9 is plus minus 5 actually. So there is a small mistake. Minus 5, which is not equal to 0. Therefore, the inverse exists. So whenever you solve matrices, let it be determinant or adjoint, okay, always make a cross check. Always check it once, because there will be some mistakes like this which can be avoided if you check it. If you do not check and proceed it as it is, then this mistake will accumulate and your final answer will be wrong. Okay, moving on to the next one. So this is our So now what we came to know, that inverse exists. Next what we are going to find out, we are going to find out the adjoint of A. So let's take this transpose. So this transpose will be equal to 1 minus 1 2, 0 2 minus 3, 3 minus 2 and 4. Find out the minors for this. So whatever we get here, that will be the adjoint of A. So the minors for this would be, so this is plus, so this row and column is gone, 8 minus 6, 8 minus 6 is 2, 2 multiplied with the cofactor, so that is becoming plus 2 as it is. Okay, next minus 4 plus 4 0, so this will become plus 3 minus 4 is minus 1, multiplied with the cofactor only I am writing here. Alright, multiply with the cofactor, whatever product you are getting, multiply that with the cofactor, do not forget that again. So here, so this is plus minus plus minus plus minus plus minus plus again. So 0 plus 9 into minus, it will become minus 9. 4 minus 6 minus 2, so that is becoming minus 2 only. So this is becoming minus 3 minus 0. So minus 3 minus 0 is minus 3. Minus 3 multiplied with minus is becoming plus here. Last row, so this is becoming 0 minus 6. So minus 6 as it is. Minus 2, minus 3, minus 5. Minus 5 with this is becoming plus 5. And 2 minus 0, it is becoming 2 itself. Okay, so just check this one once. Minus 2 plus 3, correct. So see here, minus 2 plus 3 is plus 1. Plus 1 multiplied with the cofactor will become minus 1 here. So there is one mistake here. So this is minus 1. Apart from this, check this one once. 0, 3 3s is 9. So 4 into 0, 3 into 3 is minus 9. So minus 9 multiplied with this cofactor is becoming plus 9. So write plus here. Okay. So yeah. So this is our adjoint. 0 minus of, so this is minus 9 only, students. So I'll just tell you how is it minus 9. So take this. Minus 1 row and minus 1 column is gone. So what is remaining? 0, 3, minus 3 and 4. 4 into 0 is 0. Minus 3 into 3 minus 9, which is equal to plus 9. Now this plus 9 must be multiplied with the cofactor here, so that is minus. So now this is our adjoint of A. So students, what you have to know here is, so whenever I said you as before, whenever you're calculating the adjoint of A or the determinant of A, always cross check. So there will be some minor mistakes, so you can avoid them if you cross check. Okay, moving on to the next one. So we got our adjoint of A, determinant of A also we got it as minus 5. Now we have to find out the inverse. So therefore A inverse equals adjoint of A the whole divided by determinant of A. What is our adjoint of A? This. What is determinant of A? Minus 5. Adjoint of A as it is, students, 2, 0, minus 1, minus 9, minus 2, 3, minus 6, minus 1 and 2. So before we write the determinant of A, let's cross check that once again. So here we'll write the cofactors, plus, minus and plus. So plus 1 of 8, minus into minus is plus, minus 6, minus into minus 1 is plus 1, 4 into 0 is 0, 3 into 3 is minus 9, minus into minus is plus again, plus 2 as it is, minus 2 into 0 is 0, 3 into 2 is minus 6. So minus 6 into 2 is minus 12, 1 into 9 is 9, 1 into minus 2 is minus 2 as it is, 8 minus, so students again see here, 8 minus 6 is minus 2 is written, let us make it as plus 2. Now it is alright, correct? So this is our plus 2. So 9 plus 2 is 11, 11 minus 12, 11 minus 12 will be equal to minus 1. So since we again cross checked, we got the correct answer as minus 1. So whole divided by minus 1. So finally you can write, therefore A inverse equal to, so this minus sign will get multiplied inside. So what will be getting? we will be getting minus 2, 0, 1, 9, 2, minus 3, 6, 1, minus 2. So this is our inverse of A. The point to be noted here is determinant and adjoint requires at least 2 times of cross checking. If you're not doing that, so there might be some mistakes like this, which will lead you to the wrong answer. The next question, students, exercise 4.5, 11th one, find the inverse of, again a 3 cross 3 matrix is given, but this time the entries of the matrix are not in form of numbers, they are in form of trigonometric functions. Okay, so we'll find out the inverse of this. Before we find out the inverse, we have to check whether the inverse is existing or not. What is the condition for that? Determinant of A should not be equal to 0. So now let us find out what is the determinant of A here. So determinant of 1, 0, 0, 0, 0, cos alpha, sin alpha, and minus cos alpha. You're finding out the determinant, right? So we will expand the determinant along the first row, that is plus, minus, plus. So now which is equal to plus 1 of minus cos square alpha minus sin square alpha. 0 into anything is 0. Again this 0 into anything is 0. So we'll write minus 0 plus 0. Take out minus sign common here. So it will become minus 1 of cos square alpha plus sin square alpha, which is equal to minus 1 of 1. Therefore determinant of A is equal to minus 1. Understood? So determinant of A is equal to minus 1, which means it is not equal to 0. Therefore what is happening? The inverse is existing. So what we'll do next is, we will find out what is A inverse. So therefore, what is A inverse? A inverse is equal to adjoint of matrix A divided by determinant of matrix A. So here we have already found out what is the determinant, that is equal to minus 1. Now we have to find out what? The adjoint of matrix A. So to find out the adjoint of matrix A, what is the very first step? We have to take the transpose of the given matrix. So take the transpose of the given matrix. So that will be equal to 1, 0, 0, 0, cos alpha, sin alpha, and 0, sin alpha minus cos alpha. Correct? So here we'll write down the cofactors. Plus, minus, plus, minus, plus, minus, plus, minus, plus again. We'll find out the adjoint of A from here, students. Okay, so transpose is already done, the first step. Now we'll find out the minors of each and every element. So what is the minor of plus 1? Minus cos square alpha minus sin square alpha. So that is minor of 1 is nothing but minus cos square alpha minus cos square alpha minus sin square alpha. So here again we'll show minus cos square alpha minus sin square alpha. If you take out minus outside, it will become cos square alpha plus sin square alpha. So this is equal to minus of 1, which is equal to minus 1. So instead of writing this, what can we write now? Minus cos square alpha minus sin square alpha, we will write it as minus 1. There, okay, minus 1. So this is done. Next, 0, this is becoming 0, this is also becoming 0. So write 0 as it is. 0 again. So this is 0, this is 0, 0 as it is. Next, 0, 0, 0, 0 again. So cos alpha. So this was becoming minus cos alpha 0. So minus cos alpha into the cofactor of this is becoming minus cos alpha only. Correct? Next, sin alpha. So these both are gone. Sin alpha into sin alpha minus 0 is plus sin alpha, but here we have minus as cofactor. So write minus sin alpha. So this 0, this and this is gone. So 0 into 0 is 0 as it is. Sin alpha, it is becoming plus sin alpha minus 0. So plus sin alpha into minus is minus sin alpha. And the last one, cos alpha minus 0. So becoming plus cos alpha. Here also cofactor is plus only. So we write cos alpha as it is. So this will be our adjoint of A. So adjoint of A also we got now. What is the next step? We have to find out the inverse of A. Therefore, A inverse will be equal to, so what is determinant of A? Determinant of A is equal to minus 1. So it is in the denominator. So eventually it will get multiplied inside the determinant. So here we'll be getting the answer as A inverse is equal to 1, 0, 0, 0 cos alpha sin alpha 0 sin alpha minus cos alpha. So this will be the inverse of A. Hope you understood this. Moving on to the next question. Number 14 from exercise 4.5. So read the question here, students. For the matrix A is given. Find A and B such that this equation will get satisfied. Okay. So here we have A square, A scalar multiplied with A, B scalar multiplied with I is equal to 0. And the operation between each matrix is addition simple. So how do we add the matrices? We add the corresponding elements, correct? So we'll start with this 4.5. A and B we have to find out. So let's start with the solution. Okay. So let us find out such that A square, right? We'll find out A square first. So A square is nothing but A into A, that is 3, 2, 1, 1 into 3, 2, 1, 1, which is equal to, so multiply them. Matrix multiplication is first row into first column, first row into second column, second row into first column, second row into second column. Hope you remember this. So 3 3s is 9, 2 1s is 2, 9 plus 2 is 11, 3 2s are 6, 2 1s are 2, 6 plus 2 is 8, 1 3s are 3, 1 1s are 1, 3 plus 1 is 4, 1 2s are 2, 1 1s are 1, 2 plus 1 is 3. So what is this matrix? What we got here? 11, 8, 4, 3. This is our A square. Now let us next find out. So this is done. Okay. So A into A, small a into A, we can be written as, matrix multiply this A to this. So we will be getting 3A, 2A, A and A. So this is A into A. Next we have B into I. So that is B, I, which is equal to B, 0, 0, B. Matrix, sorry, scalar multiplying B with the identity matrix. So now we got all the three. We got this as well as this. Substitute it with the signs in between and that must be equal to 0. Okay. So start with the substitution. A square is nothing but 11, 8, 4, 3 plus AA, that is 3A, 2A, AA plus BI can be written as B, 0, 0, B. So this is equal to what? This is equal to 0. So that again can be written in the matrix form 0, 0, 0 and 0. Now add the matrices on the left hand side. You will be getting 11 plus 3A plus B, 8 plus 2A, 4 plus A, 3 plus A plus B. Correct? So these both are zeros, only these both will get added. 8 plus 2A as it is plus 0, we are not writing that. Here also same thing, 4 plus A plus 0, we are not writing that. See this element 11 plus 3A plus B, and see this element 3 plus A plus B. So this will be equal to what now? This will be equal to 0, 0, 0 and 0. Now equate the matrices. So equality of matrices. This is equated to this. This is equated to this. This to this and this to this. So which one shall we take first? I think we should take this. It would be easier. Correct? There is only one variable and another number. So here we can write 4 plus A is equal to 0. Correct? 4 plus A is equal to 0. Therefore what is A? A will be equal to minus 4. Check whether this is satisfying for this case. In the place of A put minus 4. Minus 4 into 2 is minus 8. Minus 8 plus 8 is 0. So this value is right. A value is correct. Cross verified also, and it is satisfying this. Now put this A value either here or here. So I think it would be better here, right? So there is a multiple for A here, but here the A is, the coefficient of A is 1. So in this equation, so that is nothing but 3 plus A plus B is equal to 0. A is minus 4. So 3 minus 4 plus B is equal to 0. So 3 minus 4 is minus 1. Minus 1 plus B is equal to 0. Therefore, B will be equal to, send this minus 1 on that side, it will become plus 1. So B is equal to minus 1. Sorry, B is equal to plus 1. Check whether A and B values are satisfying these both equations. Let us check here first. 3 minus 4 is minus 1. Minus 1 plus 1 is 0. Same thing here. 11, 3 into A, that is minus 12. 3 into minus 4 is minus 12. Minus 12 plus 11 is minus 1. Minus 1 plus 1 is again equal to 0. So therefore, these both, A is equal to minus 4 and B is equal to 1, are the values of A and B, such that these values of A and B are satisfying the given equation. So this is your right answer. Okay, moving on to the next question, number 18. If A is an, so this is an MCQ student, and the very last question of exercise 4.5. If A is an invertible matrix of order 2, then determinant of A inverse is equal to what? So what do we know here? So solution will start. So what do we know, students? We know that A into A inverse is equal to I. Okay, this is very similar to what? This is very similar to 3 into 3 inverse is equal to 1. Correct? 3 inverse is nothing but how much? 3 inverse is nothing but 1 by 3. 3 and 3 will get cancelled, we'll be getting 1. The same thing is happening here, but this is matrix. Now they're asking determinant of A, right? Take determinant on both the sides. So determinant of A dot A inverse is equal to determinant of I. So what is determinant of I? Determinant of I is nothing but like this, 1, 0, 0, 1. So find out the determinant, it will be equal to 1. Okay, so this is equal to I. Now this determinant again can be written as determinant of A into determinant of A inverse is equal to determinant of I is nothing but, determinant of I is nothing but 1. We have to find out determinant of A inverse, right? Keep this here, send it on that side. So determinant of A inverse is equal to 1 by determinant of A. Is this option present? 1 by determinant of A, that is option B. So this is your right answer. So we have completed all the important questions from exercise 4.5 of NCERT. Moving on to the next exercise.